Hello, everyone. So today I'm going to be going over the validity of actiograph for measuring energy expenditure in healthy adults. Again, this is a systematic review and a meta-analysis. So what is actiograph? It's an accelerometer, which is a small electronic sensor that measures acceleration, which is the rate of change of movement. Again, in simple terms, it detects how fast something speeds up, slows down, or changes direction. So when it comes into the context of physical activity and health research, accelerometers are usually worn on the hip, wrist, and ankle. And then again, they detect body movement in three axes. So up, down, side to side, and then forward and backwards. The raw signals are converted into activity counts or step data, which can then be used to estimate three different things. The three different things that it can be used to estimate are going to be energy expenditure, which is calories burned, intensity of activity, which can be light, moderate, or vigorous. And then the last one is going to be sedentary time versus active time. So here, the next slide, we have the introduction. So within that introduction, we're going to go over overview and purpose. So the first one we'll go over is overview, which is physical activity, energy expenditure, which is a key health indicator. And then, so the next one will be accurate PAEE measurement is critical for health monitoring, weight management, and again, the research. So the gold standard is indirect calorimetry, which is IC, and then double labeled water, which is DLW. Actiograph tracks, so accelerometers are widely used because they're portable. Again, they're cost effective and then easy to deploy in both a research and real world setting. Some of the concerns that were in this was actiograph accuracy and did the accuracy vary with activity types and intensities. So the purpose of this study was to conduct a systematic review and meta-analysis to evaluate the validity of actiograph accelerometers for measuring PAE in healthy adults. Again, we wanted to compare actiograph readings directly against IC, which is going to be the gold standard. And then again, we also wanted to identify strength, weaknesses, and contexts where actiograph can or cannot be replacements for the gold standard tools. So here on this slide is the Prisma flowchart, which the next slide will kind of describe the Prisma flowchart as well. But this is just an overview and a visual of it. So going on to the methods part. So in the methods, we have search strategy, eligibility criteria, study selection, and then again, quality assessments. So just kind of break this down and go through them. So the first one we'll go through is search strategy. Search strategy went through a database, multiple databases actually, which consists of PubMed, Web of Science, and then Sports Discus. And then they used the range from 2010 to 2023. They also use keywords like GT3X and then Actiograph GT3X. Manual searches for additional studies were also done as well. For the eligibility criteria, so participants were healthy adults who could move without assistance and then no contradictions. Studies must use actiograph triaxial accelerometers along with IC at the same time. They also wanted to they also wanted to analyze validity, correlation, or agreement between actiograph and IC. And then again, all the studies used in this had to be published in English. The study selection. So the initial search was 4,738 articles. And then after screening and exclusions, only 20 articles met all the criteria. So with the quality assessment, they used the Downs and Black checklist. Again, the mean score for this was 11.35, which was a moderate quality. And then the Cosman checklist, which was reliability and validity score, came in at a 65.8%. So here we have the results. So with this, it has two different results. We have the systematic review and then the meta-analysis. So going over the systematic review first, this looked at 20 different studies. The average person was about 28 years old and then had a BMI of 23. Devices that were used were the Actiograph GT 3X series. And then most were worn on the hip, but some, again, were worn on the wrist and ankle. This compared to the gold standard, which is IC. And then study quality was okay, but it wasn't perfect. And then again, some key points. The results differed, but studies used different setups as well, which kind of made the results differ. So going on to the meta-analysis. So again, this chart over here is the forest chart, the forest plot chart, which again goes along with the meta-analysis. So the meta-analysis used 20 studies total, and then again, 8 studies were combined in the meta-analysis. So when researchers compared the actiograph accelerometer to the gold standard, they kind of found out that on average, the actiograph gave almost the same results. As you can see, the black dot over here, which is on zero, again, just basically means the overall difference was basically zero. So going to the next one. So this means it can be used to estimate total daily expenditure pretty well, but the results weren't consistent across all activities. And then we'll get into more of that in future slides. So in some studies, the actiograph underestimated energy use, especially during low intensity activities like sitting or walking. And then in other studies, it kind of overestimated the energy expenditure, especially in high intensity activities like running or cycling. So again, going back to the forest plot here, again, this sums up all of the 8 studies that were used. Again, each green square is the one of the 8 studies. Again, the black diamond on the bottom equals the overall average. So since the diamond is centered on zero, there's no overall difference between the actiograph and IC. So some big takeaways for this is the actiograph is good for general monitoring of energy expenditure. It's less reliable if you need precise numbers, but for specific activity or intensity, again, it's going to be kind of less reliable. So again, going on to most important to least, and then connecting other research phases. So starting off with most important to least. So again, the most important one here is actiograph is valid for energy expenditure, but again, overall it gives results close to the indirect calorimetry, which is the IC. It's not always accurate for specific activities. Again, it underestimated low intensity, and then it overestimated high intensity. It was good for general monitoring, so it can track daily physical activity in large groups. And then caution in clinical and sports settings. So it's not precise enough when exact energy numbers are needed. So connecting it to other research phases. So this is going to fit into larger research on the benefits of physical activity. Again, it shows how measurement tools like accelerometers help us better track activity and link it to health outcomes. And then again, the last one here, it connects with studies on cognition, disease prevention, and fitness, since accurate measurements is needed to understand these benefits. So again, here with the next slide, we have practical applications, and then we have strengths and weaknesses. So starting off, we'll go over practical applications. So the use of actiographs to monitor overall daily activity in research schools or fitness programs. It's helpful. It's helpful for large groups, so it's easy to wear. It's cost effective, and then again, it's portable. It can also guide public health programs by showing activity levels in the population. Again, it's best used when we want general trends, but it's not precise. Again, per activity energy numbers. So some of the strengths here. This is the first big review and meta-analysis focused on actiograph validity. It covered a wide range of devices, placements, and activity types. And then again, it had a clear and systematic approach, which was followed by the Prisma guidelines. It had a strong foundation. Again, correlations with indirect calorimetry during walking and running. So some weaknesses in this. So the studies use different methods, devices, and equations. Again, accuracy was activity dependent, so better for walking and running, and then it was weaker for sitting and cycling. Most participants were young adults. Results may not apply to elderly or clinic groups. And then again, the overall study quality was moderate and it wasn't very high. So for some future studies here, we want to standardize protocols. So again, we want to have the same wear location, intensity levels, and then duration, so results are easier to compare. Again, test actiographs in different populations, so elderly, children, athletes, and clinical groups. We want to improve or develop better prediction equations for low and high intensity activities. And then again, compare actiograph to newer wearable technologies like smartwatches. We can also combine accelerometer data with other measures like heart rate for better results. And then again, my personal takeaway, again, in my own personal opinion, I feel like actiographs worked well when you're just trying to track general activity in groups. But then again, I wouldn't count on it if I needed exact data for one person. Again, they're useful for the big picture monitoring, but I'd still lean on that gold standard method for more accuracy. Thank you.